Hello, hello. So we are talking about nonlinear inequalities. So first of all, sorry if you're printing this out, that the image is pink. So I don't know how that's gonna, don't try and print this, okay? You don't need to. So if you just look at the graphs on your device, there's not too much to write. So just use your own paper. Don't bother printing this one out. Sorry. Anyway, okay. If you saw something like this, 3x plus 7 is less than 9, right? We know how to solve this. We've done it 100 times. You even know how to do it if it's an absolute value, right? Remember all of this? Okay. So what we haven't really looked at yet, that, well, we kind of did, but what happens if you have a quadratic? That's an inequality. So let's just pick something simple like x squared plus 2. When is that less than, I don't know, 0? When is that going to be negative? Is that ever going to be negative? How do you find those values? What if I wanted to know, okay, well, when is x squared minus 7 going to be less than 0? There are certainly values here, right? Like if I plug in, I don't know, 1 for x, I'm certainly going to get out a negative value. But if I plug in 10 for x, I'm not. What happens when I plug in negative 10 though? Do I get a positive? Do I get a negative? I don't know. So we are going to be investigating, like, how do you find the answers to this? And so today, we're going to start off with the easiest of the methods is to actually look at the graph. So let me zoom out here. So what I've given you on this worksheet, you have the graphs already graphed. And I'm asking you for each one, for what values of x will that statement there be true, that inequality, okay? So let's just look at the first one. I want to know, when will my function f of x, when will it be greater than or equal to 0? So if I'm looking at the graph, it's actually pretty easy to see where it is. Let me switch to highlighter here. Greater than or equal to 0, right? So greater than or equal to 0 would be right here. This region of the graph has my function being greater than or equal to 0. So all I need to do is I need to, I'm going to write that in my interval notation to represent those values. So I want to ask myself, well, what are those x values for this portion of the graph? And it looks like I'm going in between. I've got, hang on one second, let me switch colors again. I've got right here is -1, and it's going to go all the way to here, which is what, -6? Okay, so in between -6 and 1, my function is positive. Okay, and then I do just need to consider the actual endpoints, right? At -6, is it holding true to this? Is it greater than or equal to 0? And at -1, same thing. Is it holding true? So let me erase everything that I drew over this. Boop, 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 boop. There we go. All right. So this thing is positive between, when we're doing our interval notation, remember you want to start from the left and move your way to the right. So the first time that it is positive is at -6. And I'm going to use a closed bracket at -6 because this dot right here is closed. Right? So I'm going to go ahead and I want to include -6. That is part of my solution. So from -6 all the way to a -1. And again, I'm going to use a closed bracket on the end of -1. Okay, so that represents all of the x values in this graph where my function is positive. All right, let's try another one. Let's move on to number 2. Okay, so here I have a function, right? And I want to know, when will this thing be less than 0? Not or equal to though, just less than 0. So since I want it to be less than 0, if I look right here, okay, it is equal to 0 at -3. So I don't want to include -3 as part of my solution because it's equal to 0 there. So I just want to, I'm going to use an open bracket on the end there. So remember, I'm looking for parts where it's negative. Actually, let's go in and highlight on our graph where it's negative. We're going to be negative here, this whole region, and then again over here. So this one's going to have two parts. I need to express between -3, and looks like it's going to go all the way to a +2. And then I have a break, and I'm going to pick it back up again at 2, 4, looks like that's at +6. Okay, so to show the regions of this graph that are less than 0, starting from the left and moving to the right, the first time that happens is at -3. So notice I use that open parenthesis, not that closed bracket. And then it went all the way to 2. Now I want you to think about this and ask yourself, should I use a closed bracket or an open bracket after 2? Remember what I'm trying to show here. Hopefully you're saying open, okay? I would use a closed bracket if I wanted to know less than or equal to. At 2, it is equal to 0. So 2 is actually not part of the solution here, right? That's why I want to use that open, the curve bracket, so that I include everything up until 2, but not 2 itself, okay? But then I do have to also represent this portion over here. So I'm going to union this with, so again, I'm going to use the open starting at 6, and then it's going to go off to positive infinity. And infinity, we always use the open bracket on. Okay, so hopefully this is kind of starting to make sense. So I like to look at the graph, figure out what parts satisfy what I need, and then I'm just going to write using my interval notation, whatever my answer is. Okay, let's try another one. Okay, we can do 3. So let's see, 3 here. Start off with my highlighter. And I want all of the values less than or equal to 0. So less than or equal to 0 is going to happen here, this whole section here, right? And then again over here. Okay, less than or equal to 0. Notice in this section right here, are there any breaks in when it's less than or equal to 0? No, so I'm going to include everything from here all the way up until I hit my first break, which happens right there. So even though this one comes up and touches 0, it's fine because I want or equal to. Okay, so let me erase a little bit of this. So if I'm coming from the left, I'm going to come from -infinity. And the first time that I am not less than or equal to 0 happens at +2. Okay, and then close bracket or open after the 2. What do you think? Hopefully you're saying close because I want or equal to, and at 2 it does equal 0. So I want to include 2 as part of my answer. And then I need to pick it up again at, looks like that's at 6. So then from, oh, and I didn't mean that because I wanted a close bracket there, right? Because I want to include 6. So 6, and then I want to go off to infinity again. Okay, all right. Let's try this one right here. And then there's at least one I want to do on the back. Okay, so this time I want greater than or equal to 0. So where is this function positive or equal to 0, right? So that would be any portions of the graph that are up here, right, in the y is positive region. Well, there aren't any parts, so this function actually never gets to be positive, but it does get to be equal to 0, right? Because remember, this is saying anything greater than or equal to 0. So I don't have anywhere where it's positive, but I do have 2 places, there and there, where it does satisfy this inequality. Okay, because it is equal to 0 there. Since these aren't ranges and they're just these values, I mean, I guess you could use it, write it in interval notation, but it's only going to happen at 0 and what is that, 5? So those are my only two places. If you wanted, I guess you could do 0 and 5 like that if you wanted. Okay, so that can happen too. You can also have no solution, right? If I had given you this, when is f of x greater than 0 for this same function, you would have no solution for that because it's never greater than 0. The highest I ever get is equal to 0. Okay, let's take a look at the next page. And I know there was at least one that I wanted to do. Yeah, let's look at 9. I think was the one I wanted. Okay, so 9. Here I want, where is my function less than 0? So let's start off with a highlighter and take a look. So less than 0. Looks like it's less than 0 in this portion up until I hit 0 right there. And then it's less than 0 again right here. So those are the only two parts of this function that are less than 0. Okay, so the asymptotes are not part of the graph, remember, so we don't need those. And let's go ahead and figure out our notation to represent this branch right here. Okay, so the first time I'm going to come from negative infinity, and then the first time that I hit 0 happens at, what is that, -4? Looks like right there. Okay, so I'm going to come from negative infinity, and I'm going to make it all the way to -4. And then do I use an open or a closed bracket right there? Hopefully you're saying open because I don't want to include 0. And at -4, it is 0. So I want everything up until -4, but I don't actually want to include it. All right, and then I'm going to have a jump again to this second portion. Okay, now this second portion, coming from left to right. So let's kind of break this down. I am not, so all right, let me switch to a yellow highlighter for this. This portion of the graph is positive, right? Positive, 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 positive. And this is going to keep going all the way until it hits the asymptote, right? And the asymptote isn't until +2. So this whole thing's going to keep going up until it hits the asymptote at 2. And then what happens exactly at 2? This particular function is undefined. That's why there's an asymptote there. So exactly at 2, I don't even have a function. But then what happens when I'm immediately bigger than 2? If it's like 2.00001, where am I on this graph? Wouldn't I be, I'd be somewhere on this part, right? I'd be way down here. But I'm certainly going to be in the negatives. Okay, so at 2, nothing's happening. But as immediately, once I get bigger than 2, I do have the function exists again, and it is negative. And it's going to be negative at 2.1, 2.2, 2.3, 2.4, 2.5, all the way up until I hit, hold on, gotta change my colors again, +3 right here, right? So there's +3. So my function is negative once I get bigger than 2 all the way up until 3, and then it stops. So I cannot include 2 because remember, nothing exists there. So I'm going to use an open parenthesis. So from 2 all the way to 3, that includes everything that's in this little branch down here, if you will. Okay, and then at 3, I'm going to use another open parenthesis because I don't actually want to include 3 because at 3 it's equal to 0 and I want less than 0. Okay, so hopefully that makes sense. You want to do one more? Okay, I'll do 11. Why not? So let's take a look-see-loo at 11 here. I know it looks like number 1, but it's really 11. Just got cut off. So I want, where is my function greater than or equal to 0? So let's start by highlighting where that even happens. Greater than or equal to 0. Well, it's certainly greater than or equal to 0 on this branch, right? It's equal to 0 right here. And then it's also greater than or equal to 0 over here. Okay, so I have these pieces to look at. So going from left to right, let's switch back. So from left to right, I'm going to come in from negative infinity all the way until, now when I hit -3, I know there's a hole right here, but it is closed right here. So my function is greater than or equal to 0 all the way up until -3, but it does include -3 because it's closed right there. So that's going to look like this, all the way from negative infinity, all the way up until -3, closed bracket. Because -3 is included in my answer. Even though there's a hole there, it doesn't matter because it's filled in down here. So I do have an answer for -3, and it is greater than or equal to 0. Okay, and then I need to represent this bracket over here. Bracket, I don't know, branch. Okay, so here, let's see. Am I going to include 3, +3 in my answer here? Well, what's the value of this function at +3? It's not this, because it's open, right? So at +3, my function's down here, and that is certainly negative, and that's not what I'm looking for this time. I want greater than or equal to 0. So I'm not going to include 3 in my answer, but I need everything greater than 3. So that's why I'm going to use an open parenthesis 3. So everything after 3, but not including it. And then I go off to positive infinity. Okay, and that's it. Those are all my parts. So try the rest of these. Let me know if you have questions. Good luck.